another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. We're also on the iTunes podcast store, but they only show the last 5 episodes or so. If you go to our website, rce-cast.com, you can find all the old shows there. There's an RSS feed added directly to your Google Reader or your feeder of choice. Also, you can find links to all of our Twitter accounts and Jeff's wonderful MPI blog and everything else. And that also means that, once again, I have Jeff Squyres, one of the authors of OpenMPI and from Cisco Systems. Jeff, thanks again for your time.
Sure, Brock. This is good stuff. And, it really does just roll off the tongue, doesn't it? RCE-cast.com. Just kind of rolls right off there, and you get all the old episodes and things like that. Hey, so there's a couple of dates coming up here that are probably worth mentioning. I will mention the first one here. So the Euro MPI conference papers this year were in Spain, which is going to be pretty fun. I don't think we've had Euro MPI there before. But the due dates for papers are at the end of this month, March 29th. So if you're not already working on your paper, you need to be working on it.
Also, I will actually be one of the speakers at Globus World this year, which is at Argonne National Lab down there by Chicago, and that is April 16th through 18th. So remember, we've had Globus on the show before, and they're coming out with some new features to their Globus Online product, which I hope to get Steve and some of those guys on the show to talk about some of the changes they're making for their web tool, which we didn't cover much in the original Globus podcast, after they announce their new features and stuff they're coming out with there. So I will be there. So if you're there, get a hold of me.
Cool. All right, well, what are we talking about today, Brock?
Today we have something that I am only anecdotally familiar with, and hopefully, Jeff, you can help out a little bit more with this one. This came in a request from a couple of different users. We're talking about Chapel, which I believe is a new language for scientific computing, which a lot of the heavy lifting there is being done by Cray. We have 2 guests with us, Brad Chamberlain and Sung-Eun Choi. Guys, how about you take a moment to introduce yourself?
Yeah, so my name is Brad Chamberlain. I'm an employee here at Cray, a principal engineer, and I'm the technical lead for the Chapel project, which means I oversee the design and development of the language.
Hi, I'm Sung-Eun Choi. I'm a senior developer with the group, and I also work at Cray and working closely with Brad.
Okay, so I threw out what I thought Chapel was there. Please correct me. What exactly is Chapel?
Your explanation was pretty good. So Chapel is a new parallel language that we're developing at Cray. We're doing it in partnership with other members of the community, primarily from academia and government. I think the one thing you said, so Chapel is very much designed to be usable for scientific computing at large scale, but we've also tried to make it a very general parallel language such that it's also attractive potentially to desktop parallel programmers who want to make use of the multicore processors that they have, for example.
So how did Chapel get started? And along with that, you said, there's various academia and government involved. Who exactly are the other organizations involved?
Oh, there's a long list of other organizations. So Chapel isn't, well, let's see. Let me start with how it got started, maybe, and we'll come back to who else is involved. So I think the short version of the story is that Chapel is something that came out of the DARPA HPCS program. So HPCS is a program started in 2001, 2002, with the goal of improving productivity on high-end systems. So the observation was that we're very good as a community at making faster and faster machines, but maybe not necessarily good at making them easier and easier to use. And so Cray was one of the participants in this program, and we looked at our systems, sort of everything from processor design, network, memory, all the way up to software, compilers, tools. And part of that was we thought that languages were an area where the community could really benefit from some new technologies and have improved productivity. So Chapel came out of that program, essentially, and was part of Cray's entry in the program.
So can you touch on, it was DARPA, but I assume it's, did Cray just get the contract for this, or who are some of the other contributors to this project?
Yeah, so let's see. So initially, the HPCS program had 5 teams, and then it went down to 3, and then down to 2. So at the point that the languages were coming about, there were 3 teams, IBM, Sun, and Cray. Each team came up with a language that they thought would improve productivity. So we worked on Chapel. IBM developed a language called XTM, and Sun developed a language called Fortress. And then there's a down select, and Chamberlain and Cray and IBM were chosen to go on to phase 3 of the program and continue doing their developments. So Chapel's been, even though Cray was spearheading the effort, it's been designed as an open source effort. So all along we've been encouraging of people throughout the community who are interested in participating or contributing to do so. And so you asked before about what other organizations are collaborating. So there have been a number of people at National Labs, Oak Ridge, Livermore, Argonne that we've pursued collaborations with, and others. And then we have academics at University of Colorado Boulder, some overseas at the University of Malaga, the Barcelona Supercomputing Center. There's probably a few dozen organizations altogether who've participated at one time or another. I have trouble remembering them all off the top of my head. Can you think of others that I'm notable ones I'm forgetting it?
University of Colorado, UIUC, Berkeley Labs.
University of Tokyo, Rice University. Yeah, so there's been a lot of interest in working on it, and I think the open source nature of it has been very encouraging of people to join in and contribute where they can, which has been encouraging.
So that's quite an impressive list of organizations. What is it about Chapel that brought them together? I mean, put a different way, why do we need yet another parallel programming paradigm / language / model? What is different about Chapel that makes it better?
Yeah, so let me start with the part of the question, why do we need another model? So while there have been a number of attempts at designing parallel languages over the years, and people love to haul out the lists of, the dozens or hundreds of languages that have failed, since the 90s or 80s or whenever. The fact of the matter is the number that have actually caught on and succeeded is quite small. So, MPI has obviously been successful if you're willing to count that as language, and I usually do because I think it really impacts the way you program. And OpenMP is successful, and UPC has had some success, and Cray Fortran has been adopted into the Fortran standard. But by and large, I think we feel that there haven't been any really great parallel languages. Most of the parallel systems that are out there are good at certain things, like certain styles of parallelism, like maybe SPMD parallelism or task parallelism, but typically not sort of at a broad swath of different kinds of parallelism, say data parallelism and task parallelism and concurrency and nested parallelism and pipeline parallelism. So they sort of have their one thing they do well. The other thing is most parallel languages we have only target a single granularity of parallelism. So MPI, UPC, and Cray Fortran are sort of process-level SPMD parallelism, things like OpenMP and pthreads or thread or task-level parallelism. But again, there's not sort of a single language that allows you to talk about different granularities or styles of parallelism all in one unified way. And I think this has also been the failure of some of the academic languages, is that they sort of, by nature in an academic language, you pick the one thing you want to work on that's novel, you work on that, and you maybe have some successes there, but the language is not broad enough to be sort of hit that tipping point where people get excited about it. And at Chapel, when we started out, we decided to go really big, like to be very general. Any parallel algorithm you can think of, any kind of parallel hardware you can imagine wanting to target, you ought to be able to do that in Chapel. And I think that while that makes it very audacious, can we actually pull this off? I think it also sort of is the thing that makes Chapel more unique, more different. It's just incredibly general in the scope of what it's trying to do. And I think that's been a lot of the appeal as far as why are people interested in using it or in participating in it as well. Sung, did you have anything you wanted to add to that?
So mostly I just want to add to extend on what Brad had just said, which is that since Chapel is a general language, it has a broad appeal, and it brings together people from all swaths of the community, people just who are interested in languages, as well as parallel systems and runtime systems, and that gives it a lot of attention in the academic community.
Yeah, let me pop back in. I think one other thing that makes it really appealing to people, in addition to all the features that we talked about in terms of general support for parallelism and locality, which we haven't talked about as much. It also, we very much tried to make it a very much more modern feeling language. So most languages we're using in HPC